Okay, this is the second last section from Pythagoras. It's chapter 3.4 on applying Pythagorean theorem to various situations, non-story problem contexts. So the first question gives you two right triangles, one missing the hypotenuse and the other missing another hypotenuse. Okay, they're both missing hypotenuses, of course, because it says determine the length of each hypotenuse. So if I take my right triangle and I attach squares to all of the legs and the hypotenuse, inside each of those I can calculate the areas based on the measurement of their length. The first leg is measuring 12 centimeters, so therefore its area would be 144. B is measuring 16, so its area is 256. Since Pythagoras said the area of the two squares attached to the two legs of a right triangle equal to the square attached to the hypotenuse, we can ascertain that the area of this square must be 400 centimeters squared. But we're not done yet. If we know that the area of a square is a certain area, then the square root of that will be its side length. So therefore the square root of 400 will be the hypotenuse length. And since that is a perfect square, it's exactly 20 centimeters long. Okay, so the length of the hypotenuse in the first triangle is 20 centimeters. I better erase this here. Okay, the second triangle gives you a little bit different measurements. It gives you a 16 for leg A, a 30 for leg B, and I don't know the length of that. So I'm going to put this time I'm actually not going to put squares on it. I'm going to apply the theorem instead of actually drawing squares. So we can take a squared plus b squared. Each of those is leg A and leg B squared, meaning the area of the squares attached to leg A and B. Added together will give you the area of the square attached to the hypotenuse, or C. I know my two legs. A can be 30. Actually, you know what? It doesn't matter, but I'm going to keep my leg my short side. So 16 squared plus 30 squared, meaning squaring both of those numbers, will equal x squared, the area of the square attached to the hypotenuse. 256 plus 900, which is 30 squared, will equal 1,100. Oh no, hold on. Oopsie daisy. Will equal x squared. So 1,156 will equal x squared. And once we get to this part of our algebraic equation when we're using the formula, I want to square root this side, and I want to square root that side. The square root of x squared is x, and the square root of 1156, I have no clue whatsoever. So I'll take 1156. Oh, I'll use a different calculator too. I'll view that as a standard calculator. And bring it on over here. Square root of 1156 is exactly 34. So I don't need to use my approximate symbol. It's exactly 34. So therefore, the length of the hypotenuse is 34 meters. 34 meters, yeah. In question 5, it says, what is the area of each square attached to the legs of the right triangle? So I'll make a little white circle in here so I can put my areas in each of those. The area of this square, since the side length is 6, will be 36 centimeters squared. Since the side length of that square is 8 centimeters, area will be 64 centimeters squared. And I have no clue what this area is, but I know that the area of these two squares, since they're both legs, the squares attached to legs of a right triangle, those two areas added together will equal the area of this, which is 100 centimeters squared. And that's the answer to the first part. The second part says, or the third part says, what is the length of the hypotenuse? Well, if the area of the square attached to it is 100 centimeters squared, then, and the formula for area of a square is side squared, and 100 is the area, then if I square root that and I square root that, the side length will be 10 centimeters. Question 7, what is the missing side length of the leg of each right triangle? So this time we know the hypotenuse in both of these. We know one of the legs, but we don't know the other leg. In this case, h, which we'll just change to x, just because I like x a lot better than I like any other variable. So if we have our formula, we'll do the first one with actual squares. We'll draw the squares. I'll put a square here, and a square over here. I know this area to be 25. I know this area to be 81. And therefore, if I want to figure out the area of this square, it's really what number plus 25 is 81. In order to determine that, I can actually take my 81, subtract what I do know, which is 25, and I realized this must have been 56. So therefore 56 plus 25 equals 81, or the area of the two squares attached to the legs equal the area of the square attached to the hypotenuse. The side length, however, will be the square root of 56 for the side length, and the square root of 56 is approximately 7.5 millimeters. Okay? For the second question, we have the same thing. This time I'm going to use a formula. So a squared plus b squared equals c squared. Instead of drawing the squares, I'm going to write the formula. My a squared, we'll pretend we don't know it. It's x. But I do know my other leg, which is 11. So 11 squared equals my hypotenuse squared, which is 15. X squared plus 121 equals 256. And really what I have here is a constant. The area of that second square, 11 squared, that area is really like a constant in an algebraic equation, which means to figure out what the area of the other one is, I'm going to simply subtract it. And I'm going to get x squared is equal to 135. Square root both sides. Square root of x squared is x, and the square root of 135, I have no clue. Am I wrong? Did I make a mistake? I made a mistake. Oh, that's what I made. Yes, thank you very much. 225. Oh, buttons. That would be 104. The square root of 104 I can estimate to be around 10.1. Maybe 10.2. 10.2. Yes, that's better. I knew that number didn't seem familiar. Thank you for the correction. Question 8 says the side view of a ramp at a grocery store looks like this if you look at it from the side. So it's 200 centimeters long, it's 50 centimeters high, but they want to know what is the length of the ramp itself. That's really the hypotenuse. I'm going to do this one with squares. The 20 squared or 200 squared is really 2 times 2, which is 4. You double that as well, which is 40. So the area of this square would be 40,000. This one here would be 5 times 5, which is 25, plus 2 zeros, which is 2,500. The sum of those two is going to be 42,500 centimeters squared, which would be the area of that square attached to the ramp itself. And therefore, the length of the ramp is the square root of 42,500, which is 206.2 approximately centimeters in length, or 2.062 meters, or 2 meters and 62 millimeters, if you want to get really precise. Question 9 says Tina wants to construct a path along the diagonal of her yard. Of course she does. What length will the path be? Express your answer to the nearest tenth of a meter. This is nearest tenth means 1 decimal place, right? Because tenths, hundredths, thousandths. Nearest tenths means 1 decimal place. So 6, 12, and x. X is going to be the length of the path. I like my squares, so I'm just going to draw squares on here. 144 is the area of that square. 36 is the area of that square. So 180 is the area of that square, which means you would have the square root of 180 being the length of the path, which is roughly 13.4 meters in length. Excuse me. Okay, the right triangle below has a square attached to it. What is the perimeter of the triangle? So this is kind of a tricky question because we have a triangle that we only really know one length of it. We know 17 centimeters is one length of it. So this distance between here and here is really the hypotenuse. And since 914 is the area of the square, the distance of that hypotenuse is the square root of 914, which, if we take the calculator, is approximately 30.2 centimeters. So now we know 2 of them. We don't know this one yet. So if I put a square on here, what's 17 squared? Y'all studied that. No, one more. 289. So we know if that's 289 and the hypotenuse is 914, in order to get the area of this square, It's going to be 914 take away 289. And that's going to give me 625 for this area. Or think of it differently, 625 plus 289 gives me the area of the square, which is 914. Since the area square attached to that is 625, the square root is 25, which means, if I draw my triangle over here again, this is 17, this is 25, this is approximately 30.2. The perimeter will be 30.2 plus 25 plus 17. That's 55, 65, 72, 72.2 centimeters is the perimeter. Add all three sides together. Question 12, we have, oh, this is a good question. The hypotenuse of a triangle cuts the circle in half. What is the diameter of the circle? So what we want to know is what is the diameter of the circle in general. So if I take this and draw 7 and 5, x is really going to be my hypotenuse, but it's also going to be the diameter. The area of this square would have been 49. The area of this square is 25. The sum of those two is 74. So the length of the diameter is the square root of 74, which is 8.6 centimeters. 8.6 centimeters. A better question would be, what is the area of the blue? Right? What is the area of the blue? Then you got a whole other pickle, but we'll do that one at a later date. Question 13 says, determine the length of the base of the triangle. So this is what we call an isosceles triangle. It has two equal sides here and a height. And if it asks us to find the length of the base, we need to use Pythagoras to figure it out, because when you drop a height of an isosceles triangle, it creates a 90-degree angle. Here we know this to be 8 and this to be 10. We don't know that number, but we could figure it out fairly easy. This is 64. This would be 100. This plus this area would equal 100. So using subtraction, I can figure out this area of the square that was attached to that part would have been 36, which makes x 6. But that's not the base. That's only half the base. Since this other half over here is the exact same measure, it's also 6, which makes this base 12 millimeters in length. Okay? Now a better question would have been, what's the area and perimeter of that triangle? The area would be base times height divided by 2, or 8 times 12 divided by 2, or 96 divided by 2, or simply 48 millimeters squared. The perimeter would be 10 plus 10 plus 12, which would have been 32. I would have made much more difficult questions if I was making this textbook. They asked you a fairly simple one. And 14 and 16 weren't part of your homework, but we will do them in a second. So I'll press pause in the video, and then we'll look at the answers to these.